Welcome, everyone. Thanks for joining us today and taking time out of your busy schedule to be with us. Today is our Masterclass, Citrix App Layering in Azure and H1 2022 product updates. Today, we are joined by Rob Zylowski, Senior Solutions Delivery Architect at Citrix Systems, Jeremy Ingram, Technical Architect at Ferroque, Todd Shu, President of Ferroque, and myself. Hi, everybody. My name's Amber, and I look after the marketing here. Rob Zylowski is a Senior Solutions Delivery Architect with Citrix Consulting Services. He joined Citrix when Unidesk, the inventor of application layering technologies, was acquired in 2017. Having worked with app layering for 12 years, Rob frequently blogs and presents topics on app layering. At Citrix, Rob oversees most projects in the Northeast of the US and Canada. He has been in consulting for over 25 years, specializing in networking, messaging, Windows technologies, as well as Citrix and VMware virtualization. Jeremy Ingram is a technical architect with Ferroque Systems. He has deployed Citrix virtual and networking solutions since 2008 and has contributed to Citrix Consulting Services Virtual Bench since 2011. Jeremy joined Ferroque in 2020 and is a frequent contributor to Ferroque blogs and webinar events. Todd Shu is the president of Ferroque Systems. His previous consulting company, TH Consulting, was acquired by Citrix in 2012, and he became the director of Citrix Consulting Services Canada. Todd joined Ferroque in 2020, and the company is now one of the only 2 Platinum Plus partners in Canada. Welcome, gentlemen. It's great to have you here.
Yeah, it's great to be here. Thank you.
Good to be here.
Thanks for having me.
So why app layering? App layering is a great way for customers with multiple images of the same OS to reduce their application management and patching overhead and to centrally manage images across hypervisors and public clouds. By separating components of an image into distinct component layers, OS, platform, apps, users, and allowing customers to flexibly push images to different platforms, app layering increases operational efficiencies in image inventory management. Furthermore, elastic layers allow less common apps to be chained to Citrix VDAs, reducing image sprawl, and user layers help solve the persistent VDI challenge for many customers. In this webinar, we'll discuss the deployment of app layering in Microsoft Azure, differences from on-prem hypervisor deployment, key design principles, experiences from the field, what's new in app layering, and finally end our discussion with a roundtable discussion. If you do have any questions along the way, please feel free to add them to the chat and we'll be sure to get to them at the end. I'm going to hand things over to Jeremy right now so you can take it away.
Okay, thanks very much, Amber. So why is app layering appealing? A lot of customers are entitled to the product with their existing licenses, but the immediate benefit and value proposition of it may not be immediately recognizable, and you'd be forgiven if you don't recognize it immediately. But within your own environment, value is realized when number one, there's an opportunity to improve the user experience with increased image consistency across delivery groups. Additionally, there's a want for increased management efficiencies and to reduce administration effort in updating applications and images. Thirdly, there's an opportunity or a need / business requirement to deploy to multiple cloud platforms, public, private, without recreating an entire image. Where we don't necessarily see strong use cases, number one, we don't have that many images to manage and maintain. 2, we already have a mature image management automation solution in place. And finally, we can't easily change that operational approach to said image management solution. But when deployed, there are definitely some tangible benefits to layered image management. Just to name a few, we update an app once and we can use it across many images just simply by parting that application layer in and out of respective images across the organization. The core applications that we configure can be used on multiple images, and they're installed and configured only once and they're containerized to ensure their functionality. In addition to application layers, we can also address extreme personalization requirements with user layers and configure elastic layers with multiple application layers rather that dynamically copy down to the VDA, depending on the user who logs in. For hypervisor and cloud support, we can deploy images into our own data center, or we can deploy them into any public cloud that we have available to us. One particular point that people may not necessarily realize is the maturity of the product and the peace of mind that that maturity brings to your environments. App layering is over 12 years old, and by no means are these bits that haven't been proven in production. App layering has layered tech for literally everything, even the quote-unquote hard stuff. So our operating systems can easily be containerized and layered, antivirus and other security-related apps with drivers, applications with specific drivers and service, and drivers can be in any layer included in a published image.
One thing I wanted to bring up there, Jeremy, is that I had a customer once that was hit by ransomware, and actually they didn't notice it until all their backups also had ransomware. The interesting thing was their app layering environment didn't have that, so they were at least able to publish new images out of the app layering environment, which were all created clean, and get their Citrix environment up and running quicker than they were able to get kind of their other environment up and running. So, you know, one advantage to app layering is the fact that every time you build an image, it's kind of building it from scratch, which is nice. You don't have all the baggage from what might have been in the images for many years kind of left over.
Yeah, definitely good experience from the field comment there. Thank you. Finally, for the benefits, with elastic layers, customers typically find the app layers or elastic layers appealing because that cuts down on the required images and the size of the images within their environments as well. So the bottom line with respect to app layering, it's a product that provides the best-in-class upgrade options for both applications and images. It's simple to modify and recreate any image that you have previously created. Images are always created clean. Apps can be upgraded or just recreated as desired. And PVS drivers can easily be updated. So we eliminate that need to perform reverse imaging on B disks. VDAs can also be easily upgraded. Overall, it's a very flexible product that integrates with our provisioning technologies, and we really are able to produce an image that snaps right into PVS or MCS for enterprise level provisioning.
Okay, I'm going to take over and talk a little bit about the design principles of app layering in Azure. So kind of what do you need, where does it sit? The first thing that you do when you're kind of setting up Azure is you're going to create a resource group for the app layering functionality. So I usually call that something like images. You can call it whatever you want. Within that, you'll have a storage account that's defined, and app layering will use that storage account to put disks in as it's managing its different packaging machines and producing images. App layering is driven by something called an ELM appliance. You get the appliance by going into Citrix and downloading it. It comes as a VHD plus a script that's used to install it. It includes, once it's installed, something called a layer repository. So that appliance has two disks. One's the boot disk. It's small, it's about 30 gigabytes. The appliance is a CentOS virtual appliance. And then there's a big disk. And as we work in app layering and we create application layers, they're stored in what's called the layer repository, which is the second disk in that appliance. We'll talk a little bit later about how big that can be, et cetera, but needless to say, that's kind of a big storage area because layers can be big, but it'll store them all there. You do want to make sure that you back up that appliance regularly because all the work that you put into app layering will go within that appliance. So the appliance will sit on a subnet, and the appliance will dynamically create packaging machines, which are the way that you create app layers, right? So it'll spin up a packaging machine whenever you need to create a layer. It does that by creating a template in Azure. You then go and deploy the template as a virtual machine, which gets deployed onto that subnet that's on there. And when it boots, it's then available for the admin to log in and install the application. After you've created all the layers you want and you want to create a published image, that published image gets created as a disk in that same storage account that we're talking about. And then you would use those disks when you deploy your catalog. The other component to app layering that you might use is elastic layering, which Jeremy brought up some of the benefits for. The way elastic layering works is when a machine boots and a user logs in, it dynamically mounts VHD files off of that share. So you will need a share in your Azure environment to do that with some type of clustered file server. And on that clustered file server, you would store user layers if you use those, elastic layers if you use those, and you'll also need a share for the management appliance to be able to do upgrades. It would download the upgraded packages to that share, and then it runs them off that share. But that's really the basics of what's involved in Azure to deploy and use the appliance. Okay. Once you know how the appliance sits in Azure, the next conversation to have is how are you going to architect your appliance? So app layering, as Jeremy said before, does support multiple hypervisors, multiple clouds. So you can have appliances where you just use one appliance and it knows how to talk to all those different things from one location, right? So you could, for instance, if you're already doing app layering on-prem, and let's say you're doing it on vSphere, you can keep that appliance on-prem and manage everything from there for Azure and just push up your packaging machines and your images up into Azure. But to do that, you have to have certain things architected a certain way in your environment. You can also have just an appliance in Azure and do everything from Azure, right? So that's all up there. Or you can use both, and you can use import export, which is something we have to move layers from the on-prem to Azure and kind of manage it in both locations. What you want to do might matter a little bit based on, do you have the same set of administrators for the app layering that you're doing on-prem and Azure? If they're different, it might make sense to have different appliances and have different administrators access those to manage them. That's not normally the case, but there are some organizations where that's true because there are different groups using different parts of what app layering does. If you have different OS layers, so let's say on-prem you're using Server 2019 and Windows 10 only, and Azure, when you deploy, you're going to only deploy Windows 10 multi-session. You could then deploy a new appliance just in Azure and it's only going to do Windows 10 multi-session because all the layers for that are going to be totally separate from the on-prem ones anyway. That will be a good separation from a management perspective to keep all the stuff that's in Azure in Azure while having, the things that are on-prem. There are things, if you're going to use on-prem to Azure, you do have to make sure you have a good amount of bandwidth because we're working with very large files. The images could be 100, 200 gigabytes. So you pretty much, if that's the case, you're going to need kind of a 10 gig connection, express route connection into Azure from the site where you put the on-prem appliance. If you don't have that, then that's a reason to have the appliance be in Azure so that you're totally working in Azure for those big files and they're all local on the network there. The other thing is if you're using elastic layering with on-prem, you need a lot of bandwidth to be able to push those elastic layers up to a share up in Azure. So kind of the same thing. In fact, I would say, if you don't have a significant amount of bandwidth, you wouldn't want to use an on-prem appliance to work on images that you deploy to Azure. It'd be better to have the Azure appliance and then either do import export from on-prem or just use the appliance in Azure. And the last thing on the side there is import export. The main thing to remember there is you need some kind of interim share to do that functionality. So when you use export, you're actually exporting the VHD files that are the layers to a share, and then imports them from that share. So you have to have some common share that both can get to use that functionality. Next slide. Jeremy?
Very good. Thanks, Rob. Just some additional notes on elastic layering. It's been a popular buzzword in this presentation already. But in Azure, your elastic layers will need to live in some dedicated file shares. Those elastic layers will need to be highly available. Clustered solutions are the best. Non-clustered shares will require a BDA reboot once a session terminates. Specific to those shares, they'll require CIFS or SMB3. Customers regularly lead with Azure NetApp files for their elastic layer shares. Azure files can also be used, but Azure files require some special configurations there, use of an API key for access from the appliance. Customers typically have the best results scaling their file share instances out in 1,000 concurrent connections. You can also use a scale out file server as well. With respect to storage types, I recommend customers typically have the best experience with the product using premium storage, and users will need read access only to access their assigned elastic layers.
Just a comment, to reiterate what Jeremy said about DFS. We do get a lot of questions about, can I use DFS and therefore DFSR for the elastic layer share? And the answer is, you can use it, it will work. The appliance doesn't understand the DFS namespace, so you have to use one of the member nodes to do that. But the big issue, as Jeremy said, is with DFS, we don't reconnect disks once they've been disconnected. So if a member fails and you have to fail over everybody to the other member, it's going to require the machines are all logged out, rebooted, and the users log in again. I have seen that used, but obviously it's not ideal. Something that's clustered is a much better idea for that.
Great, good points, Rob. Thank you. So moving on to our Azure setup. As we go through the setup process, here's really what we're setting up in our initial deployment. We're going to want a dedicated resource group for app layering activities at a minimum. Depending on your solution in Azure, your footprint in Azure, and the number of machines you're supporting, of course, we recommend a dedicated Citrix subscription. But at a minimum, definitely a dedicated resource group. Within that resource group, you'll have your ELM appliance, we'll have our packaging machines, and we'll have a storage account where those published images will reside, as well as the packaging machine disks. We'll need a service principal as well. You don't have to have a dedicated service principal for app layering. You can use the service principal that you're using for Citrix DAS. But customers definitely appreciate the added versatility that a dedicated service principal gives them. That service principal will then be used in configuring your Azure connectors, and we'll need contributor permissions on the resource group and the network for said principal. Shares, similar to deploying on-prem, we still need file shares to complete the setup on the ELM to store the metadata and the updates. We'll also need to create a delegated domain join account in AD. And if possible, again, we'll want to use separate subscriptions for Citrix, but at minimum, you want to have those app layering resources and overhead contained within a dedicated resource group.
More on the installing. When you install the appliance, I think I said before, when you get it, you download a VHD and an installer script, which is a PowerShell script. The basic process to this is relatively easy. You log into Citrix Cloud, you download your appliance so that you have it available. It's a PowerShell script, so you'll open an ISE so that you can run the script. It does use the AZ module for Azure, so you'll need to install that module. You can Google that, but basically it's install module -name AZ and -repository PS Gallery -force and -allow clobber. The force and allow clobber will make sure that if you have an old version of the AZ module, that will replace it, right? It'll actually write over it and won't stop it from installing. But you'll want the AZ module installed. Then you log into Azure and you run the PowerShell script. The PowerShell script has some defaults in it that it'll take, and it'll prompt you for other things. So when you're running it, you could let it create the resource group and storage account if the service principal you're using is actually contributor on the subscription, so that it can do that. Most people don't do that, so you would pre-create the resource group and the storage account, and you would then, when you're prompted, you type those in. It just prompts you for all the stuff that it needs. That script takes about 45 minutes to run, and what it really is doing is taking the VHD, uploading it to create a VM, creates the VM for that, and boots it up and configures it and makes sure that it works. It's, you know, within an hour, you can get that all up and running and ready to use up in Azure. The next thing that you'll do after you create that is you'll want to create your OS layer. And the first step in creating an OS layer is creating what we call the gold image, right? And that's basically what we're trying to do is create a disk that has your Windows image on it that you want to create the OS layer out of. So in Azure, it's a little easier than otherwise because normally you'll start with a marketplace VM. And you'll just bring that up and then configure that very slightly. You know, you want to make sure it's patched and up to date. And then you might want to do things like install C++ redistributables if you need newer versions, or .NET if you need newer versions onto that. What you definitely don't want to do is optimize it at this point. You want it to be plain Jane vanilla. You're then going to install what we call our gold image tools, which are the tools that go within the OS that you're managing, which is downloading. That comes down as the package when you get the app layering appliance, and you'll run that executable on that image. And that executable will unpack and create a directory in Windows setup scripts that has a bunch of scripts and other software, including the drivers that get installed for app layering. So you'll then go into that, run those drivers to install them. And then you'll use a script called import oslayer.ps1 within that. And it actually takes that marketplace VM that you're on and uploads it into the appliance as the OS layer. So if we look at that, that's a similar thing that needs the Azure module installed on the image. So you would do that same install kind of that you did to install the appliance on the image itself. And then you would run the import oslayer.ps1, passing it the appliance either FQDN or IP address, so it knows what to talk to get to the appliance. And you want to pass it -ignore cert errors because it won't trust the certificate that's on the appliance because it's a self-certified cert. That'll then go through kind of a process of downloading newer scripts that it needs. It'll prompt for credentials to the Elm to make sure that you're allowed to actually upload that. It creates a session with the Elm and then asks you for the version name for the OS layer, the size of the OS layer, the description of it, etc. You can take the defaults for those things and enter what you want. It's not too important. You can always change those things later. When it gets all of those prerequisite parameters that it needs, it'll then create what's called an offload compositing virtual machine, which will copy the disk from that into the appliance as the OS layer. And then you'll have an OS layer and be ready to go and create your app layers, platform layers, et cetera, and move on. All right, back to Jeremy.
Yeah, maybe just one additional point there. When we're selecting our image from the Azure marketplace, I'll give an example. If we're creating an OS layer for Windows 10 multi-session, there's a lot of different flavors of that OS in marketplace that we can choose from. We just want to make sure that we're deploying as close to the bare core OS as possible. So don't pick an image that has Microsoft 365 pre-installed on it. And FS Logix typically ships with a lot of those Windows 10 images. So after you deploy that, you'll want to remove the FS Logix agent that ship with the image, because of course there's a dedicated layer for FS Logix that we configure there.
Great points. Those are good points, Jeremy. Thanks.
Okay, great, thanks. So let's talk for a minute about Azure connectors. There's two connectors we'll configure in the ELM for use in Azure. The regular Azure connector, this will be used for creating our packaging machines and creating our templates. And this is where we'll be prompt to use to create the packaging machines. That'll all be stored in the Citrix AL image templates folder. After installing and configuring our layers from these templates here, this is where we'll do the shutdown to finalize and really seal up our layers and finalize them. When we actually go to publish our finished image, we'll use another connector. We'll use the machine creation for Azure connector there, and that is specific to published images. So once our image actually is assembled and presented to us, it won't be booted like the other machines that we use with the Azure connector to create our layers. This will produce our disk image that's ready to provision to be picked up by MCS and rolled out into production. A couple quick points on the Azure connector. Number one, the wording can be slightly confusing if you're going through this for the first time. The client ID in your Azure connector configuration is really the application ID, or the setting that should be ported in from the application ID from when you're performing your app registration, when you configure your service principal. The client secret as well. If you can't access the client secret for your service principal that's been created for Citrix DAS, then this might be justification for a dedicated app layering service principal. But if you haven't been through that service principal creation process with app registration yet, it's just important to note that when you create your service principal in the app registration manual, you'll need to copy the secret ID when it's immediately created. And again, if you're not familiar with the app registration in Azure process, that secret ID will only be available to you to copy for your documentation at the time of creation and not afterwards.
Though you can, one thing to remember, you can have multiple of those. So if you don't know what it is and nobody knows what it is, you can create a new one, like on that screen there where the little plus is, and then you can use the new one. I wouldn't remove the old one because you might have something else using it at that point. But you can add multiple so that you can see them again, assuming you have rights to the app registration.
Yeah. Okay. Quick word on setup, configuration, and time estimates. Time to complete app layering tasks in Azure is slightly longer than the comparable tasks you would complete in your on-prem environment. Once you've been on the tools and have a few layer builds under your belt, these are realistic time estimates to complete the various app layering tasks in Azure.
Yeah, I think the key one there that's different in Azure is the time it takes to build a packaging machine is definitely a bit longer because we came out with offload compositing for some of the on-prem ones. But it's not so bad. You'll get used to it, and we're hoping that it'll be better in the future. Okay, we're gonna jump ahead to the next step. So as Jeremy talked about, you use that Azure connector for MCS to create the disk that you use to deploy images. And the way that works is within app layering, there's a section where you create what's called an image template. And in that image template, you define the size of the image, which OS layer you're going to use in that image, all the app layers that you want to use, kind of check off each one, which platform layer will be used, which publishing connector you use. And then whether you're using elastic layering or user layering, those can be enabled or disabled as part of the image. Some customers use that feature, some don't, right? So it's up to you whether you enable them or not. You then publish that image and it will take the defined publishing connector. And the publishing process is pretty simple. The app layering appliance does this work, and it'll first clone the OS layer to a new VHD file. Basically, we're copying at a block level for that one VHD to the other. It then takes that and takes each app layer in order from the oldest one to the newest one, and it applies any of the changes copies any of the files in from that layer that are in that layer, and makes any of the registry changes from that layer, and it does them one by one. So first it'll do the first one, then the second, etc. That's why in app layering we talk about priority, and that newer layers have a higher priority. And what that really means is we're going to copy over any settings from the older ones to the newer ones if they're the same, because we're applying them one by one. The one with the highest priority is the platform layer. That means we apply that last. And after we apply that, we have a single VHD that we then push up, in this case, into that storage account that we defined when we created the app layering appliance. And then that's ready to be deployed by MCS. Then when you're going through the MCS wizard and it says, hey, which image are you using? We're actually going to work our way down through the resource group first, right? So you see in the picture there, if you look, it has that Serve Tech Layering resource group. Then it has a storage account, the Azure Connector Store, and then it always is going to have Citrix AL images as a container within that storage account, and we put the images within that. And if you have really good eyes, you'll be able to see that there's an image name first, then an underscore, then a date timestamp with a VHD. So that tells you the name of the image that you're deploying, which was defined in your image template, and then the date and time of when you published it. And that's how you can do your version management. So when you're going to look for an image, you'll find the date time of the one you're expecting, and you'll apply that either to create a new catalog or apply to your existing catalog to update it within MCS. And that's kind of how easy it is. Now for PVS, it's a little different in Azure. And the problem is, if you might know, Citrix provisioning for Azure is brand new, but it does require a Gen 2 VM to work. We don't allow anything else for Citrix provisioning in Azure. And unfortunately, the connectors that we have for app layering in Azure don't allow us to make a Gen 2 based image. So you can't directly support PVS from app layering in Azure by publishing the image directly into PVS like you do with our on-prem products. What you would have to do is publish the image as an MCS image and then use our relatively new image portability service to migrate the image from an MCS image to a PVS image. And we'll talk a little bit later about how that process works and what's new, because that's pretty new. But the IPS stuff is based on REST APIs that we've defined. And you'll install a new kind of cloud connector to drive that process and use either REST API calls, or we've provided PowerShell that do the REST API calls that can automate that process for you to move the image from an MCS image, let's say, to the PVS image, if that's what you want to do.
All right. So experience from the field, as with anything kind of Azure related, it seems there's lots of kind of lessons learned from the field working with any technology. We want to make a point to call out 3 specific ones here. And the rest of the ones we have listed here, I think, are going to make or this slide in particular is going to make an excellent kind of blog. So if you're familiar with the resource section on our website, expect to see this in blog form shortly. But so number 1, experience from the field, and this is really just app layering fundamentals that have been consistent as long as Rob has been doing app layering synergy sessions. Export and indefinitely store your initial OS layer after it's captured. Super, super important. In fact, I can remember certain synergy sessions from 2018 where it was stressed that if you learn one thing from that session in particular, it's this: the need to store your initial OS layer capture.
Yeah, and the reasons for that are, and it's best to learn this early. In app layering, we tie all of the layers that you create back to that OS layer, and they're actually tightly integrated with that. And that's because there are lots of things in the OS layer that an application might remember. It might remember short file names, short folder names, GUIDs that are part of the OS, and other things. So we actually don't let you take app layers from one OS layer and just use them on another OS layer. So if you are going through and you're upgrading your OS layer and you get to the point basically where you break it but you don't realize it, then you delete the older versions. If you can never go back to a good version that you knew worked, then you have to basically throw away everything for that entire OS layer, which includes all the app layers as well, and start over. So by keeping, making the gold image plain vanilla, so there's nothing special about it, so you'd never have to go back before it, and making sure when you import that, you have that always available to you. You can always recover back to a known good place. And you won't get into that situation where you have to redo all the work that you did, especially if you're creating, 50, 100, 200, we have some customers with 800 or 1,000 app layers. So, you don't want to have to destroy all that and do it over. So that's why that's the number one item that we wanted to bring up here today.
All right, play the classics. All right.
Yeah.
Okay. Secondly, OS layer creation in Azure. At the moment of this webinar, only Gen 1 VMs are supported due to limitations with the current connectors. Important to note, though, Citrix is currently working on some updates to said connectors that will support Gen 2 VMs, and that'll be significant for supporting app layering on PVS, as Rob mentioned, and also with Windows 11 rollouts.
Right, and I know we talked about it before, but if you're used to the on-prem app layering where you could create an OS layer and actually on the appliance go and import it from the appliance, you can't do that in Azure, right? In Azure, you have to use that import OS layer script to drive the import process so that it'll do that. And that's because most of the marketplace VMs now use a managed disk, and we need to, the only way that we can handle that managed disk with app layering is to use the script that creates a offload compositing machine to import it. So it just became part of the process there.
Okay. And the third point here, just a quick note on sizing and leading practices around sizing when you're creating your respective layers. The OS layer, that's going to be about a 60 gig default, and unless you typically need to grow your OS layer, usually that default will work just fine. But as you build your base images, that could also kind of influence the size of that initial layer too. On app layers, typically 10 gigs are sufficient for creating an application layer. Whether or not you use that 10 gigs or not, the layers will be thin provisioned. So the actual finalized size of your layer will be smaller likely. The exception to this is going to be your Microsoft 365 layer. As the updates come down, this layer can grow beyond 10 gigs. So typically, I like to lead with a 15 gig Microsoft 365 layer, and I think that's an appropriate size.
Yeah, a couple things there that are good to know too. You just need to make the layer size when you're making it big enough for what you're doing. It doesn't have to be big enough for the future because you can change that size. So let's say like you're doing Microsoft 365 and it initially installs as 12 gig, and then for some reason you think it's going to become 18 gig. When you go to do that addition that's going to make it 18 gig, you can make it bigger then, and it'll actually make the layer bigger at that time. So you're not stuck with what you put in there. You can change that every time you add a version to a layer, and that can change it. I do get questions a lot about why is the layer so big? I went in, I created a layer, I put 3 text files in it, and it's, 1.2 gigabytes, right? Which obviously is not the size of those couple of text files. One thing to remember with app layering is what we're actually doing when we create a layer is that we're creating this packaging machine we're creating a blank disk on that packaging machine, and then that's assigned to the layer. And from when that machine boots up to when you finalize it, everything that's written on that machine goes into that disk and becomes part of the layer. So there's a lot of temp files. There's a lot of things in that really don't matter, but they do take up some space. So pretty much the smallest layer that I've seen is in the, like 400 or 500 megabyte size limit or whatever. They're never going to be really small with a layer because of that process and the way it works.
Oh, good tip, thanks.
Okay, and then the next session we wanted to talk about that we promised is what's new in app layering, kind of as of this webinar. One of the really big things that's new is that we have finally finished the new HTML5 console in app layering. And if you've been around app layering, you know for years we've used Silverlight. In fact, it was for 12 years that we used Silverlight. But Silverlight is no longer supported, so we had to get off it. So we had been over the last several versions adding more and more functionality to an HTML5 console, and that's now finally complete. Pretty much everything that was in the Silverlight console is available in the new console. However, I will say if you're used to the old console, you will have to find each of the features because they're all in different places in the new console. And we're still working on the new console for usability. I think the engineering team realizes that what they've set up got it done, but it might not be the most usable version of, so we will continue to make that better now as the new versions come out. But you can definitely do everything you need to do in the new console. In fact, Silverlight's not available. The old console is not available at all, nor is the old URL for it. You'll see if you go to, I think it was admin UI before on the appliance, you won't see anything. You have to go to the new URL to get to it. Another thing that was added recently was the ability to run custom firewall scripts when you use a user layer that get run right before you log in. So there's a script in the scripts directory for doing this, and you can modify it to make changes to the firewall if you need to for the user layers to work for users. We now support Office 2021 as part of app layering, which means we've included the scripts for activation for KMS within that. And of course, we're always adding OS support. The latest version of app layering, which is 2206, supports Server 2022, Windows 10 21H2, and Windows 11 for those hypervisors that support it. Windows 11 is one reason that we're really creating new connectors for everything to make sure we have offload compositing connectors, because it's required for Windows 11 that it use a TPM and that it's UEFI. So we have to be able to support UEFI on all of the platforms that we support. So we will be coming out with new connectors for the ones where we don't have an offload compositing engine, which right now is, I think, Citrix Hypervisor, Azure, and Nutanix. I knew there were three that were part of that. So those guys will all get new connectors that can support offload compositing so that we can do Windows 11 as part of that. And then the last thing we wanted to talk about before we get to the discussion part of today's webinar is that image portability service, to kind of explain that. So I said before that if you want to do PVS in Azure, you need to use this. The image portability service is actually a new service that we came up with to help people take images from on-prem and move them into the cloud service, like to Azure or other cloud. Currently we have Azure or Google Cloud. We're working on AWS, and there'll be more things in the future. But it's a scripted-based workflow where we can move from an on-prem PVS to either PVS or MCS in the clouds, or the other way around, on-prem MCS to PVS or MCS in the cloud. And it's deployed as some REST APIs. And then we've written some PowerShell to help people that don't use APIs generally to do this, that want to use PowerShell. And it's a relatively easy process, though a little complicated to set up. But basically what we're doing is we're taking, let's say I'm going to use the PVS to PVS example, because there's a whole bunch of different ways you can do it. But we have to take a vDisk And then we have to get that vDisk up into Azure in our example. So we have a script that we provide that both copies the vDisk, which is a VHD or VHDX, and makes it a managed disk up in Azure. Right? So you'd run that process, it would copy it up into Azure and make a managed disk. The next part of that process is something that we call prepare. And what we're really doing in prepare is we're bringing that managed disk up as a VM. We're going in and uninstalling the VDA and the target tools that you have installed there from whatever versions you have, and installing the appropriate ones for the cloud platform that you need. And you in the script, you kind of define what that version is, but we're basically replacing the PVS device tools and the VDA in that and saving that. And then there's a third process called publish, where we take that disk that we prepared and we push it out into a share and add it into PVS. So the easiest way to do this is you would share out the stores on both sides, and then you could get that vDisk right from the store, push it up into PVS, modify it, save it, and then push it out into your store in PVS and add it back into the PVS server. But this is an automated process, so the hard part is configuring the script in the first place, but then you just have to let it run and it'll do that process for you. That's really the newest thing that I would consider as part of app layering, even though it's not specifically app layering. It uses all the app layering technologies to do these things as part of that.
Awesome. Well, that was a lot of great information. Really, really appreciate that. I'm not sure, Todd, if we have any questions. I feel like we probably do.
Yeah, we actually have
like
quite a bit of questions. Yeah, we see a lot of questions. So we're gonna go one by one. So the first one, OS layering, OS layer switching feature still in beta?
So yeah, we call the OS layer switching feature in labs. It'll never get out of labs. So that's something we added really from customer demand, and it can work, but it's something our engineers are never comfortable with, right? That's why we haven't, it's been there for years. What this feature is the ability to use an application layer across different OS layers. And remember, I told you before, the reason we try to keep them together is because when you capture an application, it might remember things about the OS, right? It might rely on those things that it remembers about the OS. With app layered switching, you're taking it and running it on another one. If the layer's like Notepad++, that would actually work fine, and you can do that. We only allow you to do that with elastic layering, though, not with layers that you put in the image, because it makes them too unstable. But it's okay to use. It doesn't mean it's not supported. It actually could be supported. It's just that we don't normally recommend doing it because we're worried that any layer you do it on might not work, is really what it comes down to. But if you sufficiently test it and you're happy with it and you're using elastic layering, it should be fine to use.
Okay. All right. Rob mentioned that the EOM using self-signed certs and to ignore during import OS. Is it possible to use a third-party cert?
You can use third-party certs on the appliance, but the problem is when you're installing the appliance, right? That's where you're kind of telling it to ignore certs. But yes, you can create a PEM file with the certificate that you want to use and the public key as part of that PEM file, and import that into the appliance to use an actual cert on the appliance. You'd still, when you're installing that, right, probably do the -ignore certs, but then you'll get a normal cert on your appliance so that when you connect to it, it's secured.
Okay. If an existing OS layer we use is exported and imported on Azure EOM, do we need to create future new app or platform layer on Azure, or can we create them in Azure or on-prem?
So if you're using the two appliance approach, you can take all of your OS layers and your app layers and upload those into Azure using import export. You definitely need to create a new platform layer that's Azure specific. The one thing to remember, and actually I think I missed it when I was going to talk about it, if you're doing an on-prem Appliance. You need to install, Azure has agent, basically drivers for their Windows machines. You want to install that into your OS layer so it's available when you create the platform layer, because you'll want to create that platform layer on Azure. And once you push that packaging machine up into Azure, if you don't have those agent tools, you won't be able to actually connect to the console, right? So you'll never be able to create the platform layer. So install those agent tools in your OS layer. It'll be okay on-prem because they won't need them, so they won't load them. But that way, if you push a packaging machine up into Azure to create a platform layer there, you can do that. You can also, and you can definitely, if you want to, sync the layers from on-prem to Azure, and then still manage them in Azure. I mean, if you have enough bandwidth, I prefer the one appliance approach, where you're just publishing things up into Azure instead of trying to keep them in sync, only because that's a manual process and you might forget sometimes to update it, in which case you might get some of the wrong layers in Azure that you haven't updated.
Okay. User layer where the user can install their own applications. How do people patch those apps when the user install on those layers?
It has to happen on the machine when the user's logged in, right? So either the users have to do it or you have to use some type of, update process like SCCM or something to update it.
Right. This is the old-fashioned way, right?
Yeah.
Okay. So for image portability service, would you recommend the same requirement for BW as for deploying all image from on-prem ELM to Azure?
So I think what you're saying is, would it be better to publish images from your on-prem app layering appliance to Azure or use IPS to do that?
Yeah.
I would probably do it from the appliance, only because I think it'll be a little more efficient than IPS. IPS has to do that whole conversion thing, and you won't need to do that if you do it from the app layering appliance. So it'll probably be quicker from the app layering appliance directly than using IPS as an interim step if you're already using app layering. IPS was really developed for people not using app layering, where they just want to take their, PVS images and MCS master images and push them up into Azure without having to go through all the work of converting them, et cetera.
Cool. Is Elastic app layering still restricted to non-persistent VDIs, or does the latest version support persistent desktops?
It's only non-persistent, and the reason really is because, well, I mean, it's a few things, but the main reason is because we can't unhook layers once they're attached, right? So you have to reboot the machine and have a new user log in, and normally with static desktops that doesn't happen, right? So.
Right. It's kind of by design, I think.
Yeah.
Yeah. So.
Now you could use the user layer, and you could use statically assigned non-persistent, right? If you wanted to, that's a possibility. If you need, the name to be the same or something for a user.
Yeah. Are there any good how-to guides for on-prem ELM or to be used together with deploying resources in Azure? This sounds like a good time for you to plug a book.
I should. I have a blog out there. It's kind of old, but it still applies, that kind of goes through how to do app layering in Azure. There's no, the whole app layering, design is for multi-hypervisor. So I think we expect that people will just get that, the fact that you have the connections, et cetera. But there's nothing out there besides my blog that I know that's specific to do this kind of thing for doing that. So hopefully this webinar helped, right, for that. And then, my app layering blog that's out there already might help you a little for that.
Well, I'll turn it into an ebook and publish it on Amazon and get paid. That's what I think you should do.
If I had time.
Awesome.
All right.
Well, I think that we've certainly gone through a lot of information today, probably too much to intake in one session, but we will be taking this webinar and posting it on YouTube in the coming weeks. on an email you'll get tomorrow, and as well on the YouTube link or description. We will be referencing a lot of different blogs and resources, including the one that Rob just talked about. Our Ferroque team has just recently published 3 separate blogs on app layering. So those will all be links that you'll have access to here in the next day when you get that follow-up email. I wanted to thank you, gentlemen, Rob, Jeremy, Todd, for joining us today. It was great to have you here, taking time out of your busy schedule to share with us your plethora of information. Well, have a great day, gentlemen. Thank you again for being here, and thank you to all of our participants for joining us and taking time out of your busy schedule. Thank you so much.
All right, thank you.